Hey everyone, and welcome back. Today we're diving into three topics you hear all the time these days, but maybe don't fully understand.
Yeah, like what is the difference between data science and machine learning?
Exactly. And then there's big data. Everyone's talking about big data. What does it even mean?
Well, you sent us some great resources about this stuff, so today,
We're going to break them down.
yeah, cut through the noise,
Find those nuggets of wisdom
the aha moments.
and get you up to speed on all three.
Sounds like a plan.
So first up, data science.
Data science.
Data science.
JavaPoint defines it as the field that uses scientific methods, algorithms, tools, and processes to extract useful insights from vast amounts of data.
Oof, that's a mouthful.
Right. So in plain English, what are we really talking about here?
Well, think of it this way. Data science is all about taking raw data, like all the stuff we generate every day online.
Purchases, clicks, search queries.
Exactly, all that, and turning it into something meaningful, something we can actually use.
So not just numbers, but insights, trends, predictions.
Right, because the goal is to answer questions.
Solve problems.
Like, how can we improve this product?
How can we predict what customers will want next?
Or even, how can we identify patterns in disease outbreaks?
So data scientists are kind of like detectives sifting through clues to solve a case.
That's a great analogy. They need that sharp mind.
And the right tools.
Speaking of tools, JavaPoint lists some key skills for data scientists. Things like knowing programming languages like Python,
And
being fluent in SQL for databases.
a solid grasp of statistics.
Oh, and don't forget communication skills.
Oh, right, because what good is all this amazing analysis if you can't explain it to anyone?
Exactly. You got to be able to tell the story of the data, make those insights clear and compelling, even to folks who aren't super techie.
So data scientists are storytellers too. That's really cool. Okay, let's move on to machine learning. I'm ready to have my mind blown.
Let's see what we can do. JavaPoint says machine learning is a subset of artificial intelligence, AI that lets machines learn from past experiences or trends and predict future events accurately.
So basically computers that learn without being explicitly programmed.
That's the heart of it. It's kind of like how we learn as humans. The more we experience, the better we get at recognizing patterns and making predictions.
So like if I show you 1,000 pictures of cats, eventually you'll be able to spot a cat, even if you've never seen that particular cat before.
Exactly. Machine learning algorithms do the same thing, but on a way bigger scale. They can process massive amounts of data and learn from it much faster than humans can.
So instead of a programmer writing specific instructions for like identifying a cat in a picture, a machine learning algorithm can be trained on thousands of cat pics and figure it out on its own.
Precisely. It's all about recognizing patterns and making predictions. Think about Netflix recommendations.
Oh yeah, how does Netflix know I'm gonna binge watch that entire season?
That's machine learning in action. The algorithm analyzes your viewing history, what you skip, what you rewatch, and uses that data to suggest shows you might enjoy.
It's kind of creepy how well it works.
I know, right? But it's also super helpful, especially when you're overwhelmed with choices.
True. Okay, I'm starting to get the big picture here, but what about those skills needed for machine learning?
JavaPoint mentions strong programming skills, of course.
And the solid foundation in math and statistics.
But beyond that, it's also important to understand the different types of machine learning algorithms.
Types. There's more than one way for machines to learn.
Oh yeah, there are a bunch of different approaches, each with its own strengths and weaknesses, but we'll get into those a bit later.
Okay, so hold that thought.
We'll do. Now on to the big kahuna.
Big data.
Big data.
Big data.
Big data. Geeks for Geeks defines big data as vast volumes of data generated at high velocity from a variety of sources.
So it's not just about size, it's also about speed and variety.
The 3 V's.
Exactly. Volume, velocity, variety. Think about all the data created every second on platforms like Facebook, YouTube, or even just from the sensors in our phones and smart devices.
That's mind-boggling. No wonder they call it big data.
It's like trying to drink from a fire hose. There's just so much of it coming at us so fast.
So how do we even begin to make sense of all this data?
That's where things like Hadoop and Spark come in. They're specialized tools designed to handle those massive data sets.
So we need new tools for this new era of data.
We do, and we also need people with the right skills.
Which brings us back to that JavaPoint article. They list some key skills for big data professionals, like being comfortable with those big data technologies we just mentioned.
Understanding machine learning concepts.
And here's an interesting one, having strong problem-solving abilities and creative thinking.
Oh, that's crucial.
So
You got to be able to think outside the box to find innovative ways to wrangle all that data and extract meaningful insights.
Okay, so we've got these three interconnected but distinct fields: data science, machine learning, and big data.
And Java Point has this helpful Venn diagram that shows how they overlap.
So it's not like they're totally separate things.
Right. They're all part of the same data ecosystem, each with its own strengths and focus.
And to see how this plays out in the real world, let's talk about a company you're probably pretty familiar with.
Oh yeah, you use them all the time.
Amazon.
Amazon. The kings and queens of data.
So how are they using data science, machine learning, and big data to rule the online shopping world?
Well, think about it every time you browse, buy, review, or even just look at something on Amazon.
I'm leaving a trail of data breadcrumbs.
Exactly. And Amazon collects it all, creating this massive data lake of customer information.
It's like they have a secret file on all of us.
Kind of. But they're not just hoarding it, they're using it to make your shopping experience better.
Okay. I'm intrigued. Tell me more.
So they use all this data, this mountain of information about what we buy and how we shop, to create these incredibly detailed profiles of each customer.
But like on a massive scale.
Oh yeah, we're talking millions, billions of data points.
Yeah.
And that's where the real magic happens. That's where they bring in the data science and machine learning.
It makes sense of it all.
Exactly. They use these super sophisticated algorithms to sift through all that data and find patterns and connections that we humans would never see.
Like what?
Well, let's say you buy a lot of running shoes,
I do love a good pair of running shoes.
and you've been reading reviews of fitness trackers,
Guilty as charged.
and maybe you even bought a book about marathon training.
Okay, you're totally profiling me now, but I guess that's the point, right?
It is. Because based on all that data, Amazon's algorithms might predict that you're getting ready to train for a marathon,
Which means...
which means they might start recommending things like energy gels,
Or those fancy running socks.
maybe even a foam roller for post-run recovery.
You're freaking me out a little bit here, but I have to admit it's pretty impressive.
It is. And it's not just about selling you more stuff. It's also about making your whole shopping experience smoother and more efficient.
How so?
Well, they use data to forecast demand, so they know how much of each product to keep in stock.
So no more out-of-stock disappointments.
Exactly. And they use data to optimize their delivery routes, so your packages arrive as quickly as possible.
So it's all about using data to create a seamless and personalized shopping experience.
You got it. From the moment you land on their website to the moment that package arrives at your door, Amazon is using data to anticipate your needs and make your life easier.
It's kind of brilliant when you think about it. Speaking of brilliance, those comparison tables from Java Point and Geeks for Geeks, they do a really good job of laying out the key differences between these fields.
Oh yeah, they're super helpful for understanding how data science, machine learning, and big data each have their own distinct focus and applications.
Like data science, it's all about using data to answer questions and solve problems, right?
Exactly. It's about finding those insights and trends that can help us make better decisions.
And machine learning is all about using algorithms to make predictions about the future.
Right. Think of it as teaching computers to learn from data and then use that knowledge to forecast what might happen next.
And then there's big data, which is all about managing and analyzing those massive data sets that are just too big for traditional tools to handle.
Exactly. It's about having the infrastructure and the skills to process and make sense of those data floods.
So even though these fields are interconnected, they each bring something unique to the table.
We do. And those tables also highlight how each field is applied in different ways.
Like data science is used a lot in fraud detection,
And customer segmentation,
targeting marketing campaigns,
all about understanding behavior patterns and trends.
while machine learning is powering things like recommendation engines,
Image recognition,
natural language processing,
all those tasks that involve prediction, classification, and automation.
and then big data comes into play when we're talking about massive data warehousing,
Real-time analytics.
large-scale scientific research.
Anywhere you need to crunch huge amounts of data quickly and efficiently.
So even though these fields are interconnected, they each have their own strengths and areas of expertise.
Absolutely. And while we've highlighted those differences, it's important to remember that in the real world, those lines are often blurry. Meaning you might have a data scientist using machine learning algorithms to build a predictive model based on data pulled from a big data system.
like we see with Amazon.
Exactly. It's really more of a collaborative ecosystem than completely separate fields.
Okay, that makes total sense. But it also makes me realize how much I still don't know. Like you mentioned earlier that there are different types of machine learning algorithms. Can we unpack that a bit?
Yeah.
I'm curious to understand how those algorithms actually learn.
Absolutely. Let's dive into the three main types of machine learning algorithms.
All right, lay it on me. What are these different types of machine learning algorithms?
Well, the first one is called supervised learning. It's kind of like teaching a kid to recognize different fruits.
Okay, I'm picturing flashcards with pictures of apples, bananas, oranges.
Exactly. You give the algorithm a bunch of labeled data. You're basically saying this is an apple, this is a banana, this is an orange.
And the algorithm learns from those examples.
Right? It starts to see the patterns, the characteristics that make an apple and a banana.
So then if you show it a new fruit it's never seen before, it can make an educated guess about what it is.
Exactly. That's how spam filters work, for example.
Yeah.
They're trained on tons of emails that are already labeled as spam or not spam. And over time, they get pretty good at figuring out where a new email should go.
So it's all about learning from labeled examples.
Right. And then there's unsupervised learning, which is kind of the opposite.
Opposite? How?
Well, in unsupervised learning, you don't give the algorithm any labels. It's like giving the kid a big bowl of fruit and saying, figure it out.
So no flashcards this time.
Nope. The algorithm has to find the patterns and group things together on its own.
That sounds a lot harder.
It is.
Yeah.
But it's also super powerful because it can uncover hidden structures and relationships in the data that we might not even know are there.
Give me an example.
Like customer segmentation. Imagine you have a ton of data about your customers, their purchase history, their demographics, their browsing behavior. An unsupervised learning algorithm can analyze all that data and group those customers together based on similarities.
So like people who buy similar products or visit the website at the same time of day.
Exactly. And that's really valuable for businesses because it helps them target their marketing more effectively.
Makes sense. So instead of telling the algorithm what to look for, it's finding those connections itself.
You got it. And then the third type is reinforcement learning.
Okay, this one sounds intriguing.
It's kind of like teaching a dog a new trick. You give the dog a reward for good behavior and maybe a little correction for bad behavior.
So the dog learns through trial and error what actions lead to the best outcome.
Exactly. And in reinforcement learning, the algorithm is doing the same thing. It's trying different things, seeing what works, and learning from its mistakes.
So it's like a little virtual scientist running experiments.
That's a good way to think about it. And this type of learning is used in all sorts of cool applications like robotics, game playing self-driving cars, even optimizing complex systems like traffic flow or energy consumption.
Wow, so we've got supervised learning, unsupervised learning, and reinforcement learning, three very different ways for machines to learn.
And that's just scratching the surface. There's so much more to explore in the world of machine learning, but hopefully this gives you a basic understanding of how these algorithms work.
It definitely does. I feel like I've learned a ton today about data science, machine learning, big data, all these interconnected fields that are shaping our world.
Me too. And it's all thanks to those awesome resources you sent us.
Yeah, those were great. But you know what's even better?
What's that?
Having you here to break it all down and explain it in a way that makes sense.
Oh, shucks.
Yeah.
Well, I'm glad you found it helpful. And you know what? I think the most important takeaway from all of this is that data is everywhere.
It is.
It's transforming every industry, every aspect of our lives, and it's only going to become more